My name is Volker Sick. I would like to welcome you together to this joint event of the Global CO2 Initiative and the OpenAir Collective. Just a few brief words about the Global CO2 Initiative. We are an organization that looks at accelerating the development and deployment of carbon capture and utilization technologies and establish those as a mainstream climate solution. And I think in that spirit, we are joined by the OpenAir Collective. And I'll let Matt Parker briefly introduce the collective before we actually dive into the DACCATHON event.
Thanks so much, Volker. OpenAir is really excited to be a part of this event and be working with all these amazing students. We are an entirely volunteer organization that believes that everyone can have an impact on fighting climate change, and we want to help people do that by using their knowledge, their background, whatever they've got to give. We're going to help them find a way to use it to fight climate change. And we are primarily focused on carbon removal, so we're really excited to be part of this DACCATHON.
Matt, thank you so much. And in the spirit of what you just summarized, a student competition fits right in. And I'm inviting Dahl Winters now to sort of give us a bit of a background of where this all started, her contributions to the initiation of this entire series, as we like to believe it will become, is. And then we hear from our student teams. Dahl.
Thank you, Volker. Well, it's been a pleasure. This date has been long in coming, and we've been working with the Global CO2 Initiative and OpenAir Collective. I'm a member of OpenAir for a long time now. We've had many student projects that all stemmed around the development of a unit that I had put together back in November 2020 called Cyan. And it's been amazing what the students have been able to do over the course of these past few months to develop a system that will make Cyan even better in terms of carbon capture, or more efficient, or less energy being used. I have been working with the students over the course of several weeks, weekend meetings on Saturdays, and it's just been wonderful to see everyone learn and grow in terms of carbon capture and learning how to make the system better and finding ways of improving upon what we were able to do before.
Wonderful. Thank you so much, Dahl. And I would like to call upon one team after the next to very briefly highlight their changes made to the starting science system, and probably a few words of what made you focus on those changes. So we'll start with team number one.
If everybody can see my screen, essentially we made two very big changes. So the first one was that we changed the use of the sorbent from calcium oxide to CKD, which is known as cement kiln dust. So cement kiln dust is a byproduct of the cement process of making cement, and it has a high portion of calcium oxide in it. We were fortunate enough to have access to a lab where we were able to test the proportion of calcium carbonate that we actually absorbed using the cement kiln dust, and found that using the original Cyan build with CKD, we were able to get a 30% CO2 uptake. The second thing we tried was actually creating kind of a complete from the bottom up build where we combined the two components. So Cyan has a component where it saturates your sorbent, and then another component where it dries it. We combine them into one thing, which you can kind of see here. We also measured the humidity and changed it so that instead of you having your sorbent kind of like in a pile on the bottom into like this vertical thing, we were capable of doing because we were using cement kiln dust, which is cementitious. So once you get it wet and it dries, you can kind of invert it vertically, and it doesn't just like all fall out of your filters. So in any case, what we had here was a system where we had air blowing through our filters and a humidity portion where essentially we had water being bubbled up from the bottom, and so it would humidify while air is currently being pulled through that filter that's containing your CKD. And after a portion of time, we would turn off the humidity so that it would just dry. Unfortunately, it didn't work that well. We got 9% CO2 uptake with that compared to the original, but it was still kind of a novel idea, and we'd like to test it a little bit more in the future.
Thank you so much, Kat. I believe team two will be Michael.
Let me just share this really quick. So the main things that we focused on was trying to get our unit to be more sustainably powered. The initial unit design focused off of a pump, which just ran directly from grid power, just plugged into an outlet of the house. What we ended up doing for one of the changes we wanted to make was having a unit which would run off of solar power. So that basic kind of setup is right here. So we had a battery connected to a solar charge converter and it connected to a solar panel outside, which allowed the battery to be charged for daily hours and basically allow the pump to run off of solar power instead of power being pulled from the grid, which in most cases is made from sources that put carbon back into the atmosphere. This was all an attempt to try and make the unit more carbon friendly than carbon negative, so to speak. On top of this, we also did a lot of work with trying to use different types of catalysts. Daniel specifically worked with trying to use salt and different types of sugars to try and get the carbon capture process to accelerate as much as we could. We had some interesting results, I believe, with using sugar as a catalyst. Nothing too major, but potentially promising. Salt didn't really pan out there. And on top of that, we also tried to do a lot of different work with changing the permeability of the surface which we sat our capture sample on. So Daniel did a lot of work also with trying to use a test tube rack and more directly focusing on having the air that the pump brought in bubble directly through the sorbent we were using instead of just being within the capture box itself.
Thank you, Michael. We call upon team number 3, and I believe Kiana will speak on behalf of that team.
So this is kind of like a summary slide of what my team did. Essentially, the focus of our design was more experimenting with the aspect of humidity in our lime-based direct air capture process. And we continued to maintain the same carbonation reaction that was happening in the original cyan design. And what we changed was the container for which the reaction was occurring in, and then also modifying the humidity conditions within that container. We have a couple of pictures of our design. We enhanced the surface area for the reaction to occur with the reactant. And then we also implemented kind of a very small scale humidifier that would essentially humidify the entire container when the container was closed. We were essentially just trying to investigate the effect of increased humidity in that way. And we weren't able to enhance the percent amount of captured CO2 too much, but it was interesting to observe for which humidities the reaction worked best and also for which humidities we had the highest run intensities. So that was really interesting. And we are also looking forward to continuing to sort of experiment with controlling humidity in this way for our further modified design in the future.
Thank you so much, Kiana. And then last but not least, we will hear from Team 4, represented by Martin.
Awesome. Yeah. So hello, everyone. My name is Martin, and I was on Team 4 along with Mahek and Shivanji. So we made 2 main modifications to our unit. And the first one was by adding in stackable layers. So it's kind of hard to see in the video here, but I'll play that in a second. But rather than having a single filter paper in our unit, we had 5 or 6 of them stacked on top of each other with space in between, so that effectively we were able to increase the batch size of the reaction with the same amount of energy input. Secondly, we added a vibrational component. So we modified a fan and then hooked that up to an Arduino that controlled when it turned on and off, so that the fan would hit the support structure where the units were being placed, and then that would cause the calcium hydroxide to vibrate, thus allowing more CO2 to penetrate within the calcium hydroxide and react. So I'll play that video real quick. It's only 5 seconds. So as you could kind of see there, the calcium hydroxide was bouncing around a lot. And so that was kind of the goal there. So in our conclusions were that the stacking was effective, as we didn't see any much of a decrease in how much CO2 was absorbed for each filter paper when we moved to that. However, we thought that adding the fan was inconclusive, and we would need to do more tests to figure out how beneficial that really was. And then finally, I think Mike and Team 2 was definitely onto something. We just did a basic analysis on the energy inputs compared to the CO2 captured, and we found that if it was powered by renewable electricity, that would really help out the case for making it an effective way to capture carbon. So I think in the future, adding that component in as well is really important. Thanks.
Thank you so much, Martin. And before I invite Dahl back to the virtual stage to actually announce the winner, let me say that the judges were really impressed with everyone's creativity and ingenuity. And with that said, I'd like to acknowledge all the judges, including Dahl Winters, Matt Parker with us here on the call. We have Professor Jerry Stokes on the call in the audience. Stefan Schwiers was not able to join us today. And then I also have to admit that I was one of the judges. We really enjoyed reading through the reports, listening in on some of the meetings that you had. And we had a really in-depth discussion about who should actually be named the winner. I'll let Dahl take it from here.
Yes, thank you, Volker. It really gives me pleasure to be able to announce today the winner of the Season 0 DACCATHON competition. It's been a while in coming. I know everyone's been waiting to hear. They're really excited. The work that you've done has been amazing. And it was truthfully really difficult to pick a winner for this competition. But I want everyone to make sure to give themselves a pat on the back for the work that you've been able to do. We are in a climate crisis, and getting this off the ground to help students such as yourselves and other students later on to be able to learn how to do carbon capture, carbon removal, how to go through this process is momentous. And I'm so glad to be able to experience this with you. So without further ado, the winner for this season's DACCATHON is Team 2, Michael Ficage and Daniel Pert.
Now that said, congratulations to all the teams. We spent a very long time actually debating back and forth because you all brought such unique elements to the competition. And I think we hear in a moment how this whole competition will go forward, and including, of course, we will have to design a trophy. For now, let me say that I would like to send to all of you a lapel pin with the United Nations Sustainable Development Goals, because I think what you all do really fits squarely into this very important set of activities. We couldn't be more grateful for what you have started. We want to see that these kind of activities emerge as an annual series of global participating student teams that unleash their creativity. We have had a lot of fun, a lot of insights based on science, and you have pushed already beyond the original idea of the constraints that we've given. So, Dahl, do you want to talk about what's next? What's the future?
Yes, thank you. I wanted to let everyone know that what you have started has the potential to continue and blossom into a much greater level of participation by universities, colleges worldwide. What we want to do next is announce a season 1 in which we have more universities participate, as well as more types of DACC. So not just the science-based DACC, but any kind of DACC that you're working on that may even be a new idea that is coming out. And I'd like to hand it over to Matt real quick to announce other plans for season 1.
After talking with organizers of this year, we've decided that we are going to do an annual DACCATHON starting in the fall of 2022, along with many of the organizers here for this summer DACCATHON. We're also looking to do some smaller DACCATHONs in the interim so that we're not, waiting the whole time to get it done. So there'll be other events for you students to participate in. Currently, a visiting scholar at the University of Waterloo, and we're doing a design DACCATHON with them that students from other schools are welcome to participate in. So that's just going to be a 26-hour in honor of COP26 for people to come up with designs, not implementations, for all sorts of different carbon removal solutions with cash prizes involved. And we're working on doing another implementation DACCATHON that's going to kick off in December, January, and go through the summer. So those will be sort of like bridge events to season 1 annual DACCATHON that we're going to kick off in fall of 2022. Thank you all so much for participating in this, and hope to see you all contribute to these other events in the future.
Wonderful. Thank you so much, everyone, for, first of all, being the main reason we have this event. You, all the students, the judges, and the audience who has hopefully seen what students can do in contributing to saving the planet. Let's make it happen. Thank you all for being here with us, and see you in the very near future.
All right. Thank you, everyone. And congratulations.
Thank you, everybody.